Hi, good evening, everyone. Good evening, everyone. It's a pleasure to welcome you all to another exciting monthly session organized by the NAIJA-Java user group. I'm really glad to have you all here. Please, can I see your favorite emoji? It's another powerful section. So I believe there are new people here, with us. So for those that are joining us for the first time, I just want to take like a minute to briefly share what NAIJA-Java user is all about, so that you'll be fully aware what is actually going on, right? So the NAIJA-Java user group is a community-driven platform dedicated to bringing together Java developers and technology enthusiasts across Nigeria and beyond, right? And our mission is centered around, learning, collaboration, mentorship, innovation, and professional growth within the Java ecosystem. Through meetups like this, technical workshop, and the boot camp that is currently ongoing, and also so many other knowledge sharing sections and engagements, we aim to, create an environment where developers at every stage of their journey can connect, improve their skill and grow together. That is a brief about our community. And as we grow and expand, we welcome partnership, sponsorship, and collaboration with individuals and organizations who share same passion for empowering developers, and advancing technology. Right now, moving on to today's section. Right, I believe you guys are happy. You can be giving us your best emoji, please. So moving on to today's section, we're excited to host Mr. Siva Prasad Reddy, who is a developer associate at JetBrains. And he'll be speaking on Spring Boot from beginner to pro. So this session is going to cover practical insight, best practices, and real-world approaches to building modern Java applications. So if you are already, getting started, or you're already, working with Spring Boot, it's a valuable lesson for you. So sit put, right? So once again, thank you for joining us. Stay engaged, and please join me in giving a warm welcome to Mr. Siva Prasad Reddy. So, sir, you have the floor. Please go ahead. Thank you, guys.
Thank you. So let me share my screen. Okay. I hope you guys see my screen, right? Okay, cool. So let me, just a quick intro about myself. My name is Siva. I'm a developer advocate at JetBrains, and I have been working with Java for the last 19 plus years. And also I have been sharing whatever I learned on my blog sivalabs.in for more than 16 years. And I'm active on Twitter, and also I publish videos on Java and Spring Boot on my YouTube channel, again, Siva Labs. And along the way, I learned some things, and then I wrote a few books on various concepts. And this is about me. And coming to today's agenda, if you are a Java developer, Spring Boot is the most widely used framework. If anybody says that I'm working on a Java project, we can safely assume that there is a good chance that it could be a Spring Boot application. That is how popular it is. And also, it is a very huge framework. And in this session, my goal is to cover the important points of Spring Boot, where you understand the core concepts of it and some of the best practices and how to debug if there are any issues, how to debug the Spring Boot applications. And finally, what are the things we should take care of while putting a Spring Boot application in production. So these are the things I'm planning to cover. But along the way, if you have any questions, please interrupt me and ask the questions, or you can post them in the chat. I'll go through it and then I'll try to answer them. Good. So starting with Spring Boot core concepts. Many times we may see in the reality today, like let's say if any of you started as a Java developer, new Java developer, and probably you have gone through some training and you have picked up some basics and fundamentals, and then they directly put you into a project, maybe using Spring Boot, and then directly expect you to understand how it works, and then you need to contribute it. But I'm pretty sure that it feels overwhelming. Why? Because this is evolved over almost 15 to 20 years. It started as a Spring framework, as an alternative to J2EE, which was not that great. And even some people who used J2EE and they left Java altogether, and then still they are kind of recovering from those bad memories. And Rod Johnson created the Spring framework as a lightweight alternative to Spring, and it kicked in and it was very successful. And the Spring portfolio grew over the time, and there are many Spring portfolio products like Spring Security, Spring MVC, Spring Integration, Spring Batch, and there are kind of a 20 plus portfolio projects. While it is kind of a much better improvement over the previous J2E platform, slowly it got a little bit complicated because you need to configure so many things, and even from application to application, people used to copy paste a whole bunch of XML Java configuration and then tweak into for the new application. So it kind of become a little bit of daunting. So that's where Spring Boot take a step back and think, how can we make it more easy so that you don't have to do this copy pasting of a common code snippet over and over and again. So that's when they come up with opinionated and convention over configuration approach. What does opinionated and convention over configuration approach means? If you are familiar with other programming languages and frameworks, for example, if you take Ruby on Rails from the Rails community, Ruby community, they are heavily relying on convention over configuration. Instead of expecting you to configure everything, they have certain convention like, okay, if you put these classes in controllers folder, we are going to consider this as a controller. If you put these views, we automatically consider this for this view navigation. So things like that. You don't have to configure everything explicitly. There are framework level conventions, and if you go by the convention, you don't have to configure anything explicitly. Only if you are going to deviate from the defaults, then only you are expected to configure that. This very idea is significantly reduces the friction. Like if you want to use a wide range of Spring portfolio projects, you don't have to configure if you just default sufficient for you. But if you want to change any default configuration or you want to customize anything, then you have the flexibility to change that. That drastically simplified Spring application development, and also opinionated. So for example, if I want to build an application and I want to talk to some SQL database and I want to use Hibernate, then before Spring Boot, you need to add all the Spring Boot and Spring Hibernate, all the JPA dependencies, and you need to configure all the Hibernate specific properties and all that. But pretty much in the Java community, when people want to use JPA, they go for the Hibernate implementation as a JPA implementation. So why expecting everyone to configure the same thing? Instead, can't we take a opinionated approach? If someone wants to use JPA, there is a very high chance that they want to use Hibernate. So instead of asking the developer to add the dependency, let us configure Hibernate as a default implementation. Similarly, if you want to work with JSON, there are multiple options available in Java space, like the JSON, there is a JSON and all that, but JSON is the most widely used one. So if you want to work with any JSON processing, let's give JSON as the default one. So like that, they took a kind of a opinionated way, where it kind of again simplified configuring the dependencies and all that. But that is very basic step. And then they went into Spring Boot starters approach. This is where things got really simplified. So here, let me exit this presentation currently. Now, if any of you already explored Spring Boot, you know there are Spring Boot starters. So here I have a very simple application, and if you open the pom.xml, we are inheriting from a parent Spring Boot starter project, and then we are simply adding a starter called web MVC. Similarly, validation. So if you have worked with Spring Framework before Spring Boot, you know it was a little bit of very challenging and painful as well, because we need to identify the compatible libraries. Like, let's say I'm using Spring Framework 5.x, and if I want to use, let's say, some other library, I need to make sure that what version of Spring Framework is compatible with what version of, let's say, Hibernate validation. I need to figure out that compatibilities by myself, and then I need to configure all of them. And as the project grows, it becomes very challenging. So this is when a Spring team came up with this starters idea, where they have already figured out, okay, for Spring Framework 5, this is the compatible MVC library. This is the compatible Hibernate validation library. This is the compatible Hibernate library, something like that. They have configured. If you just step into Spring Boot parent POM, again, it extends another parent POM here. If you go to this one, here you can see in the properties, they have defined all the compatible libraries with Spring Boot current version 4.0.6. So most of the libraries, plugins, whatever you use commonly, they have already verified the compatibility and configured all of them. And they have defined all these dependencies in the dependency management section. That means the dependency is verified, and it is going to work just fine with this Spring Boot version. And depending on your application needs, you just can add a dependency without having to specify version. So if you take go back to our application, here we are not specifying any of the dependency version, because all these are compatible, and their versions are already specified in the parent one. And not only Spring specific, they have various other libraries as well. For example, one of the commonly used libraries is Apache Commons Lang. Let's say Commons Lang 3, something. So they have already defined this in the dependency management section, which means it is not automatically added to your application, but it is there in the dependency management section. If you want to use this library, you can simply go ahead and, let's say, add in its dependency and commons lang. So here I can just use it like this. I don't have to specify the compatible version, because it is already verified and configured in the Spring Boot parent form. So that is how simple the dependency management became. Now, if you take a look at the Spring MVC starter, if you go here and if you explore, when I add web MVC starter, I would like to build a MVC application, probably using it can be a web application for exposing REST APIs. So it already configured Jackson dependency. It already configured Tomcat as a servlet container. It already included Spring Web MVC dependencies. So that dependency management got drastically simplified. You don't have to hunt for the compatibilities and all that. You just add the starter. And for example, in this case, validation, you don't have to again check what is the Hibernate compatible implementation. So here they have already added Hibernate validator 901. So that got really simplified. If you have worked with Spring applications prior to Spring Boot, you know how painful that was and how much Spring Boot starter simplified the whole process. And one of the next main key feature of Spring Boot is auto configuration. Again, as I said earlier, in Spring applications, you need to configure various beans. Like if you are using Web MVC, you need to configure dispatcher servlet, and there are a whole bunch of beans that you usually configure to support Spring MVC. But then Spring team identified, okay, this is kind of a repeatedly configuring the boilerplate in every application. Why can't we just automate this one? So this is where they get the idea of auto configuration. What does auto configuration means? Let's say I just added this dependency, which obviously means I want to build a WebMVC based application. So instead of asking the developer to configure all those beans, they are going to automatically configure by taking some sensible defaults. And you don't have to configure anything. And if you simply add this and start it, it is going to take all the sensible defaults and start it. But what if I want to change something? I want to change, let's say, the path of the servlet context, or I want to change the HTTP listeners or something like that. So that's when we have the provision to explicitly configure. So the best part is, if you don't configure anything, Spring Boot is going to take care of automatically configuring with the sensible defaults. But the moment you override any of that configuration, or you provide your own customized bean definitions, Spring Boot is going to take a step back and allow you to use whatever you configured. They don't configure. For example, let's take a look at Jackson auto configuration. So if we add Web MVC, it automatically add Jackson starter as well. And within Jackson starter, we have this Jackson auto configuration. So here, if you take a look at, we have this, it's a auto configuration class, and it is having this annotation of conditional on class. So if your application has this class in the class path, then only the beans defined in this auto configuration class will be registered. Otherwise, it won't register. So for example, even if you add any of the starter which has this auto configuration, but if you do not have this class on your class path, none of these classes are going to be active. So it is simple. And also within this bean is going to be automatically registered. And if you take a look at this bean registration, it has a bean registration and at conditional on missing bean. What does this mean? If you yourself have not configured a JSON mapper builder bean, then it is going to automatically register this as a bean. But if within the application code, if you register a bean of type JSON mapper, and maybe you have a different implementation, then Spring Boot is going to take a look at your own configuration and see, okay, there is a JSON mapper builder being already configured by the application itself. So I don't have to configure this bean. It is going to take a back step. So like that, Spring Boot will give us the default sensible configuration, but allows you to override it if you want to change any of the defaults or you want to customize anything. So that way, even if the developer is new to Spring Boot, if they simply follow the guidelines like adding the necessary starters and all that, it is very easy to get started. And another major pain point that was solved by Spring Boot is configuration management. So before Spring Boot, again, every team has their own preferences. Most of the enterprise applications, they have different configuration properties. For example, the applications might be talking to a database, might be talking to a RabbitMQ, might be talking to FTP servers. So there could be a lot of configuration. And there is no such a standard. So some people say app.conf. They put all the configuration in app.conf.properties. Somebody says application config.properties. So there is no standard. Every team is following different naming conventions, and there is no standard. And that's when again Spring Boot team think, why can't we simply make it as a standard so that you don't have to explicitly say my application configuration is in so and so file. Let's standardize on the default application.properties so that you don't have to tell the application that, hey, my configuration is in so and so file. Make it as a default. And if developer wants to change, there is a provision. Otherwise, you don't need to specify anything. Just provide your configuration in application.properties, and Spring Boot is going to take care of taking all this configuration into account and start the application. It is as simple as that. Not only this, there is a concept of profiles. So profiles basically, you want to, if you want to register some particular beans, only if you enable some profile. For example, if you are running your application in a local environment, maybe you want to have a different configuration. If you are running your application in a QA environment, maybe you want to talk to a different database. If you are running your application in production, obviously you want to talk to a production database, something like that. So in such cases, again, let's standardize this and then simplify it. So what they did, you have all the default application properties in application.properties file. This is the default. And you can have application hyphen, whatever the profile name you have, and you specify the profile name and you configure the properties. So if you want to just enable any of the profile, just enable, and it is going to automatically take care of overriding the default properties with local properties. So again, before also we can do this before Spring Boot, but again, we need to explicitly configure all those things. But right now with Spring Boot, you don't have to do this. For example, let's say we have started a Spring Boot application and we did not enable local profile. In IntelliJ IDEA, you can already see it is kind of showing in a grayed out color, which indicates that a local profile is not enabled and the properties are not loaded. Properties from this local properties file. So now if you, let's take a look at how, if I enable the local profile and then start the application, now we can see here it indicates with the green icon that both the application.properties and application-local.properties files got loaded. And also from the application properties, you configured the default of page size as 10, but you have overridden that in local profile to 5. So if you take a look at here, IntelliJ already shows you that, okay, it got overridden. And if you want to know where does this value change, if you click here, it will take you to the configuration file where we are overriding this. So if developers are new to Spring Boot, this is very handy to know, okay, where does this value getting overridden. Not only this, Spring Boot also provides various levels of options to customize the properties. So here we have seen one way. This is the default and this is the local profile properties, but we can also override them using environment variables. So the default is you take the property key, capitalize all of them, and replace dot or dash with underscores. For example, I want to override this at the final runtime deployment time. I want to override this through environment variable. How simple it is let's say if you again go to configuration and let's add environment variables. Here, let's go and page size. As I said, we just capitalize it and replace the dots or hyphens with underscore. And let's say I want to configure it to 25. Now, with that configuration, so here again, it identified that that particular property is overridden using environment variable. If you click here, it shows, okay, this value is overridden using environment variable. So that is how simple it is. If you want to manage the configuration, you have the defaults, you have the profile specific properties, and even after all that, if you want to change the properties, you can change them through environment variables. Of course, in production, you have even more options like a Spring Cloud Config Server, or if you are running your application on AWS or somewhere, there is a parameter store or secret manager, things like that. You can hook up all these configuration management tools. So Spring Boot already thought through how do you manage your application configuration and already make it as simple as possible. Another core concept of Spring Boot is embedding the servlet container environment within the application fat jar itself. Before Spring Boot, the way we used to deploy our web application is you build a WAR file, web application archive file, and then you have to set up whatever the application container you are using, be it a Tomcat or JBoss or any other servlet container or application server. Then you have to build your WAR file, and then you deploy it in the server. It's kind of a two-step process. Not only that, different servers have different ways of customization. For example, if you want to configure thread pool size or change the ports and all that, each server has a different way of configuring. So what Spring Boot folks did, instead of deploying our WAR file into the container, how about bringing the container jars into the application itself? So you can build one Uber jar or fat jar, and you don't have to set up a Tomcat or a JBoss or whatever server. You just need one jar and anybody can simply run it. It's much simpler. Not only that, they kind of give the simplest option where you don't have to figure out, okay, if it is Tomcat, there could be a Tomcat.xml file, and then there you need to change it. If it is a different Jetty server, you have to change in a different file. Instead, they made it possible to change all of them through application configuration itself. For example, here, if you want to change any Tomcat specific properties, you can change it. If you have Jetty server instead of Tomcat, you can change Jetty properties here. So you don't need to worry about which properties file or which XML file I need to tweak if you want to customize any of the containers. So that is how these are the core pillars that anybody should definitely understand before getting into Spring Boot application development. So any questions on this so far? Okay. Yeah.
Yeah, from my end, just from my end. Can you hear me? Hello?
Yeah. Now I can hear.
Yeah, so from my end, I'm just a bit curious on the part of, auto configuration, right?
Mhm.
Because when you walked us through it, there are a lot of things happening. There are, a lot of things to be injected, like the Jackson auto configuration. So I want to understand, like, at what point in the, application does this auto configuration come in? Is it at the point of startup? And what mechanism does the whole Spring Boot engine uses to carry out this auto configuration?
So basically, Spring Boot application, when you configure beans, either through adding the annotations, for example, here, let's say we have a book service. So you can register a Spring Bean using annotations like this, or you can register using add bean Java configuration methods. And after all this configuration, when you start the application, that's when all this auto configuration kicks in, and it is going to scan through all your code base, not only your code base, but also all the dependent starters and everything. It go through all those and then register the beans. So how does this starter registration and everything happens? If we take a look at some of the, let's take a look at the jar files. Okay, so here we have auto configuration module, and let's say we can say, okay, let's take a look at another one. Okay, so if you take a look at the Spring Boot Flyway starter, and here there is a Spring factories file within meta-NF, and here it already listed all the auto configuration classes that needs to be loaded. So when you start the application, Spring is going to take care of looking at this and then automatically loading the auto configuration classes, and within each of them there can be bean registration beans, and again considering conditional on so and so class and conditional on missing bean. Based on all this criteria, it is going to create the beans and then finally create an application context.
All right, great. Thank you very much. And one more question, please.
Yeah.
Does this have any impact on the startup time? Since it's doing a lot of things on startup, does it has any impact? And also, is there any way to like optimize? Like, is there any inputs,
Yes.
from the developer to like make it faster? Yeah.
Yeah. So basically, the more starters you add, the more work Spring has to do, because it has to scan through all of them and then go through all the identifying which bean needs to be registered, which doesn't have to be. So Spring has to do all this work when you start the application. And as I said, the more starters you add, the more time it is going to take. So this is one of the reason they came up with the Spring Native, where you are going to take care of looking at, okay, what are the classes I need to load and how to auto configure all these things at the build time itself instead of starting the application time. And it is going to perform all the identifying which beans needs to be registered and pre-processing all that, so that you don't have to do this bean registration using reflection when you start the application. And also you can produce a binary instead of as a jar file. So Spring Native is one approach to look at if you want to optimize for bootstrap performance thing. And not only that, it is going to eliminate all the unnecessary class loading and everything. So if you are very curious about improving the performance, take a look at the Spring Native, GraalVM native support.
Okay. Thank you very much. Thank you. I appreciate it.
Cool. Okay, let's move on. So now that we talked about the fundamentals, what about some best practices? Here again, some of the concepts are not specific to Spring Boot itself, but also there are a lot of things we can talk about. But typically I would like to touch upon things that we mostly work with. Even till today, most of the application use SQL databases and use some OR frameworks. So I would like to cover some of the aspects around those areas. And so here, when you are building, let's imagine we are building a web application, and typically you have three layers. One is your web layer, where if you send a request, your controller will handle the request, and it is going to take care of unpacking the request parameters or request body into some Java bean. It takes care of marshalling all that, and then that's the job of controller layer. And then once you extract all the necessary data from the HTTP request, you are going to delegate the actual business logic to your service layer. So when you invoke a service layer method from controller layer, you kind of assume that it is going to be a unit of work, which means you perform one entire use case as a service method. And within that service, you may need to call multiple repositories to interact with the database, and you may have to perform multiple database operations and then execute some business logic. So you need to plan in such a way that your service layer method should be a unit of work. And then there is a database layer, repository layer, where you talk to different databases. It could be a database, a SQL database, or NoSQL database, whatever. So it is highly important to separate that concern so that you don't add the data interaction within the controller. Of course, there will always be some scenarios where if you don't have much of a business logic within the service layer, if it is a simple, very simple service layer where you are just delegating the calls to repository, which is kind of in that case, maybe you can skip the service layer. But in any production grade applications, there will be business logic, and you should have the three layers where you can segregate the responsibilities into different layers, so that if you want to change something, ideally it shouldn't affect the other layers. So that is very important. Not only that, if you properly segregate things like that, you can have a clear boundary of transactions. Typically, you don't start the transaction in the control layer. You start a transaction in the service layer, because that is the one use case that you are exposing as a service method. So the scope and of the transaction is a Spring service method. So if you have clear segregation, it is easy to demark, okay, where does the transaction start? Where does the transaction end? You can clearly use the annotations accordingly. And there is, like, if you ask Java community, do you like ORM frameworks? You can see people form in two groups, and then they debate till end of the time, like why using ORMs are bad. And then there is other group that says if you don't use a ORM, you are going to slowly build your own custom ORM. Instead, you should learn how to use it effectively and then use it. So you have that debate going on forever. I would say, if you are going to use ORM like Hibernate and you are going to use along with Spring Data JPA, you should definitely understand how better way we need to use, and most importantly, how to avoid some of the anti-patterns. Because when you are building a Spring Boot application using Spring Data JPA and talking to some SQL database, most likely in our local environments, we don't have huge data set. In our, let's say we are going to spin up a PostgreSQL instance, and there could be a few records for testing. And then we just verify whether the functionality, whatever we are implementing, is working or not. We don't really see any performance issues during the development time, because there is no huge data. And everything seems to be working very well. And then you put the application into production or any higher environments where you might have thousands of records or even millions of records. That's when you start getting alerts saying that this is terrible, it is very slow and all that. And then you have to go into the mode where you figure out, okay, where does the things going wrong? Why didn't I come across the same issues during the development? So you have to explore all these things. And there are certain things like some N+1 select problem, OSIV filter. So these are the very well-known anti-patterns that we should understand and avoid them. Otherwise, they are going to really cause problems. So let's take a look at how what they are and how to avoid those issues. So first, let us take a look at our sample application here. We have very simple REST API. We have a book controller, and simply if we invoke /API/books get request, here we are calling book service.getBooks, and again we are simply loading all the books from the database, and then we are returning a list of book entities. And if you take a look at the book, it's a JPA entity, it has some properties, and also it has a one-to-many association, which has a list of reviews. So this is a very simple model. And then once we are getting the list of books, we are converting them into a DTOs, and then we are returning them. Nothing complicated. And okay, we have started the application also. And if we go to localhost 8080 API/books, we even got the data. We got the books and we got each book's reviews as well. So everything seems to be working just fine. But now, if you take a good look at the console, it is bombarded with a bunch of SQL queries. So first, it ran one query to fetch all the books, and then it executed more queries to fetch users' information who posted the reviews, and also it executed more queries to load the reviews. So usually this is what is called N+1 select problem. You fire one query to get the list of things, and then you fire N queries to fetch the associated data. This is commonly known as N+1 select problem. So this is a huge problem. Like most of the juniors who do not understand the behind the scenes things, they simply write this and then assume everything is fine, but it blows in the production environments. So how can we fix that? So instead of loading plain data from books, and then it is loading associated data as you try to convert them into DTOs in this bookmarker. So here, as we navigate through a list of books, and then we are trying to iterate through reviews and then creating the reviews, then it is issuing one more query to load the additional reviews of a particular book. But here, if you notice, we have the controller here, and then we are loading book service.get bookmarks. And usually here we have the transactional annotation. That means it is going to open a transaction here, and it is going to load the data from repository here. And it is only loading the book, not reviews, because we have the lazy association type. But it should fail, right? Because the scope of the transaction ends right here. And if you try to load the associated child collection, which is lazy, and it is beyond the transactional boundary, ideally, it should fail here. Within this bookmarker, book mapper, it should ideally fail. But it didn't fail. It worked just fine. Why? Because the default is in Spring JPA opening view. It is true by default. Unfortunately, this shouldn't be, but that is what it is for various reasons. And if you take a look at, there is some warning that logged out. Spring JPA opening view is enabled by default. Therefore, database queries may be performed during view rendering. In our case, we are marshalling it as a JSON response. So even though the transactional boundary is defined at the service layer, because of the open in view filter enabled by default, when you try to convert the book entities into book DTOs, it is opening another session, and then it is loading additional data in this at the controller layer, which is not really recommended. It is convenient, but it is definitely not recommended. Ideally, you should load all the required data for a particular use case from the service layer, and you should disconnect the session so that it should ideally fail. So the best way is simply disable this open in view filter, and then let's see what happens if I restart this. So now if we if we try to access this, it failed. And if we take a look at it, it shows lazy initialization exception, because we are trying to load a lazy child collection of reviews in the book controller, which is not having any associated session. It is failing. This is a good thing. It should fail, so that we know that there is something wrong in our the way we are loading the data. And now we should think about how to fix it. So again, if you go into book repository here, one way is we simply called a find all. That is one way. Instead, we could use a custom method, and then we can write our own query here by left joining with book reviews, and then loading the associated user, all using left join. So if we use this method instead of default find all, let's see how the behavior would be. So now again, it started working fine. But if you take a look at the console, there is only one query it triggered to load all the data using joins. Instead of firing tens or even hundreds of queries, it just load all the necessary data using joins, which is a much better way than ideally. In this case, I'm just demonstrating loading all the books and their associated reviews. But in real use cases, you should never load all the data at once. Most of the times you should go for pagination. But here the point is, don't rely on simply defaults and then assume it works just fine. Take a look at all the times, take a look at the configuration and what kind of queries that are being generated behind the scenes, and then try to fine tune it. So this is very important for most of the database driven applications using ORM frameworks. This is something that we should be really careful about. So basically here we have seen how N+1 select problem is, and how we should carefully try to disable the OSIV filter, because that is very convenient to get started. That's why they made it as a default true. But 99% of the times, you should not use that. You should disable this filter. And also, let's take a look at. So Spring Data's API also provides a very convenient way to write the derived queries. In this case, let's take an example here. Here we have find by email and password. So we don't have to actually write the query. Spring Data's API figures out, looking at the name, it is going to strip off this find by and then try to derive a where class using this expression, email and password. So what it is going to do, it is going to trigger a query saying select user from users table, where email equals to whatever the value we are passing here, and password equals to whatever the value we are passing here. So just by the naming convention, it is automatically deriving this. Feels pretty good and also very convenient. And for this case, this is fine. It is actually fine. But many times user might also have enabled or verified, those kind of flags, and you want to load only a verified user. If the user is not yet verified, you don't want to load that entity. So what people do, they just keep adding enabled true, and then more things come and verified. So it keeps going on, and people find, okay, just because it just works, they go on add and or and between all those kind of things. While it just works, it is pretty much a very bad idea, because instead you should really give a meaningful way and use a query instead of just keep adding and or all these things. So if you are using IntelliJ, there is a very nice option to automatically change that. Let's say in this case, my intention is to log in the user. For the given credentials, I want to load a user. So if I press option enter, I have an option like extract JPL query and configure. If I press it, I can change the name to login. I want to have the method name as login. And also I want to use named parameters. If I click OK, IntelliJ automatically figures out, okay, let's change this. But before that, the method name was find by email and password. So IntelliJ automatically takes care of creating a JPQL query where it has written the JPQL automatically for you. So I would say use meaningful names. Just because we can use the find by blah, 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 doesn't mean that you should do use meaningful names here. So the last one is we should understand how a transactional works. So most of the times people just don't worry about how transactional works. Simply commit books, whatever the service layer, and simply add a transactional and hope it works fine. For the most cases, it just works fine. But again, there can be different methods. For example, here, let's say, I'm just trying to demonstrate something. So let's imagine there is another method, and if you invoke this, let's say you are invoking this. Okay, so what happens? If you call this method from controller, here it is going to start the transaction. And then it is going to execute this method call here, whatever the logic you are executing within this same transaction. Even if you have a transactional here, it doesn't matter because it's a local method call. It doesn't start any additional transaction here. And everything that is executing within this is going to be running in only one transaction. But in this case, it really doesn't matter because both of the annotations using the same thing, and there is no problem. But the problem is, if you want to run this method, let's imagine the propagation level is set to requires new. So usually people, what they assume, okay, we have used propagation requires new, which means if you are invoking this getBook1 method, it is going to start a new transaction, and whatever the logic that is here, it is going to be run in a completely different transaction. And the assumption people make is, if they call getBooks, this is going to run in a different transaction. When we call this method, it is going to run in a different transaction. And then let's imagine if they are making some changes to the database, they are going to be committed in a different transaction, and then this logic is going to run in this transaction. But that is not how it works. If you directly call this method from a different class, then this is going to take effect. But if you are calling this method from another method within the same class, it is not going through proxy. Instead, it acts as a local method call, and it doesn't take this annotation into account. So here, if you see, it is not the way it works. So if you want more explanation around it, let me So on my blog, I have, let's take a look at Spring Boot tutorials, and there is a database transaction management article. So in this, I try to explain. So usually, this is the service we write, and then we implement whatever the logic we have. And when you add the add transactional annotation, Spring Boot is going to take care of creating a proxy around the service, and it implements the logic to start the transaction automatically, committing the transaction if everything is fine. But if there is any error, it is going to throw exception. All that logic is implemented in the proxy. So if a client is calling a method, they are not actually calling a method on the user service itself. Instead, they are making a call on the proxy. That works just fine. But the problem is there should be, yeah. So here, if somebody is making a call, let's say register user, and then within that, there is another method called create profile, which has the transactional requires new. But when they call this register method, that's when a proxy method invocation happened. But within this method, if they're calling another method, even if it has a different annotation, that doesn't take into account. It is going to be a simple method call, local method call that ignores all the annotations here. So it is very important to understand the proxy mechanism, and this is a common mistake many people do about misusing the transactional annotation and assuming that just because we have the annotation here, it is going to work just fine. But if you are calling this method directly from the client, it works fine, starting a new transaction. Or if this method is in a different service, that also works fine. But if you have the same in the same class, and if you are making a local method call, that's not going to work. Either you need to restructure your code to make it this method as a separate class and then call it, or there is another way to make it work, but usually people don't go into that route. So that's about the transactional and some of the best practices around. Any questions on this one? Okay, so if there are no questions, I'll move. So the next one of the important point is, how do you structure your application? How do you organize your code? So there are different ways and there are different schools of thought, but it is one of the important thing to worry about when you are structuring and working on a large scale application. For example, if you are working, let's take a look at an example. So here I have an application. Let's switch to package by layer. So here in this application, I am using typical layered architecture. Here I put my services in one package and all the repositories in one package, controllers in one package. So this is a typical layered style code organization. If you are building, let's say, a very small microservice, this is fine. There is no big problem with it. But if you are building a bigger application, structuring the code in this way, at beginning, you don't see much problem. But as the application grows, it is going to become a mess. Why? Because when you put all the repositories in this and when you put all the services in here, if any other package wants to call any of the methods, obviously they needs to be public. To be exposed to the public, you need to make everything as public. The moment you make all the classes or interfaces as public, anybody can call it. Let's say today I need some product information, but initially what we assume, okay, product service is the owner, and it is going to talk to product repository to return any product related information. That's how it starts. But then sometimes later in some other service, you need some product information, and then you thought of, okay, why should I call product service? Why can't I simply access product repository? They will simply go for injecting product repository and then call it. And it seems to be working fine. But now there is no clear ownership here. If you want to change the product catalog management, now both order service and product service are already depending on product repository. So if you try to change anything, there are more than one thing that is going to be affected. So for simpler, very simple code base, this layer package being layer is kind of okay, but the application grows, it is not very scalable kind of a code organization. A better organization would be like a package by feature. So in package by feature, the way we structure our code is, instead of putting all the controllers at once, all the services in one, you try to structure in a modular fashion. Like here, we have a catalog module, we have inventory module, we have notification module, and orders module. So if you put anything in the domain, let's say I have structured in a way that I have all the web layer components in the web package, and my whole domain, core domain logic goes into this domain package. Now I can make some classes as package protected. Here, if you notice, there is no public class, which means this cannot be accessed by any other module. This is only accessible within this one. Similarly, order mapper, it is not a public one. Similarly, let's say order repository, it is not public one. So if anybody else even try to access it, they can't. It is not exposed outside of it. This is only scoped within the particular module. The key benefit here is you have full control over. Let's say you want to structure, you want to move this method to a different one. You want to move some service method into a different one. As long as the code is private to a particular module, the other people does not get affected, because this is an internal refactoring. You can change the structure, you can split one service into multiple services. So all the things that you can do within the module is allowed, as long as it is not going to be affected by others. Whereas in the previous way, package by layer, the moment you make it public, you lost the control. Whoever wants to inject, they have the visibility, they can inject and they can call your methods. And then if you want to, let's say, change the method signature, that could impact many clients. So this is why you should structure in a way that you should package by module or feature, and make as many things as possible as private. Don't make everything as public. Make most of them as internal to the module and expose. In this case, the only thing we want to expose is service, not the repository, not the entity. We have some models. Because we don't want to expose our JPA entities which are tied to the database, we don't want to expose them directly. Instead, maybe we want to expose some DTOs. So like that, try to make as many things as possible as private internal to the module. Expose only the things that is absolutely necessary for other modules. So this is a very key idea. So here we have structured like that, but again, this is kind of a faith-based, like you explain this to your team members and everyone agreed to it. But then you are relying on the good graces of the team member, assuming that they are following these guidelines and all that, because there is no automated mechanism to verify this. Whether we are violating anything, there is no clear way. So this is where tools like Arch Unit, if you have ever explored, there is a library called Arch Unit. So what this Arch Unit library can do, we can write some kind of a test and verify that, okay, this module should only depend on this, or only controllers should call these services, or a repository should not be accessed by anything else apart from services. So those kind of guidelines you can create as a test. so that if somebody violates them, it automatically fails the test, and then you can take care of, okay, here we are violating the principle and we should refactor the code. So that is one library that can be useful. But there is a Spring Modulith, one of the recent addition to the Spring Boot family of components frameworks. So Spring Modulith provides, actually that is built on top of Arch unit, and also automatically provides many of the verifications. So here we have, let's see. Okay, here it should. Okay, so here, if you take a look at it, you can see Spring Modulith automatically assumes this is your root package where you have the main entry point, main method class. So this is the root module. Within that, each of the top level packages are considered as a module. Here, catalog is a module, common is a module, inventory is a module, notifications. So each of these sub packages within the root module are considered as a module. Within this, if there are any public classes, so here product API is a public class and product TTO is a public class. So these are the components that is exposed to the public, which means any other modules can access these public classes. But if there are any nested packages, they are automatically considered as the private components of this particular module, which means even if one, let's say product entity is a public one, right? And technically Java compiler allows you to use this in a different, let's go ahead and let's see. Product entity. So here technically it is compiler allows you to access because product entity is a public one. But Spring Modulith says that it is within a sub package which is considered as a private part of the catalog module. So you are not supposed to call. So all these guidelines are enforced so that you don't have to worry about assuming that your developers follow these guidelines. You can enforce them as a testable architecture. So here, this is a private component. These are all the private components. You can see the red closed lock icon, which indicates that this is a private part of the base module. But what if I want to expose some classes, not only the ones that are public here, I want to expose some more components. How can I do that? So here, if you take a look at, so here in orders package, we have domain, but within the domain, I have models. So I want to expose these components to the outside of orders module. So what I can do, I can create this package info and make it as a named interface. I can give whatever the logical name I want to give. So if I make it as a named interface, then I am telling the world that yes, domain is a private, but I am making an exception that this model package and its components can be accessible for other packages. So that way there are certain rules, and it kind of whatever the ideology we have around package by module is ensure that it is properly implemented. Otherwise, let's again go back and make a violation here. So here, let's say product entity. Okay, so let's imagine we have written the code like this, and there is a Spring Modulith test, modularity test. So here we create a modules instance, and we can simply call modules.verify. So if you call this, it is going to check did we violate any of the issues. So here our test failed, saying that module users depend on non-exposed type product entity. So it is saying that you are trying to use product entity which is non-exposed type. It is a private component of the catalog module. You are trying to use it. Even though compiler allows you, you are not supposed to call that. So Spring Modulith catches those violations as tests. So you can make sure that the architecture is not only conveyed to the team, you can enforce that as a executable test as well. In my opinion, if you are working on any greenfield projects, I strongly recommend you to check Spring Modulith and structuring this. Even if you have code base growing, this ensures that each module is well structured, and even later point of time, if you feel like okay, catalog is getting more and more traffic, I want to make it as a separate microservice, it is very easy to simply move this into a separate microservice, and because you have isolated all the code that belongs to catalog. So it is much better. You can start as a modular monolith, and then based on the need, you can extract sub modules as a separate microservices if need be. Any questions on that? Okay, if there are no questions, I'll move on. So about Spring security, most of the applications use some sort of a security. But my suggestion is implementing security is not that easy. For most of the applications, there are a range of attacks that can be done. So Spring Security already implements most of the features as a framework level features. But again, implementing your own security solution, I would not recommend, because you need a lot of security related conceptual understanding to properly implement that. Instead, you should, if possible, you should use any of the out-of-the-box solutions like a Keycloak or Okta or something like that, where the experts build those solutions. They already take care of a lot of those security concerns and everything. So if it is feasible, we should go for using those solutions instead of reinventing and implementing our own. And also, when you configure your Spring Security, already by default, Spring Security, the moment you add a security starter, it logs down all the API endpoints. But sometimes people by mistake enable access to the whole paths and then try to narrow it down for certain things, which is not recommended. Instead, by default, you should log down all the API endpoints and explicitly configure only, okay, if you want to expose it to without authorization, only explicitly configure them. That way, even if some configuration, a new endpoint is added, that is already logged down, and it's a conscious decision that you want to expose it to the public. It shouldn't be by mistake automatically exposed to the public. And in fact, I would say avoid managing the passwords itself, because you need to ensure that you are storing them with the proper encryption and all that. It is not too difficult, because we already have all the encryption algorithms and everything. But if at all possible, avoid managing the passwords yourself. Probably using social login, if that is works for your business, go for it. Recently, one-time password is getting more and more popular for logging in. So I would recommend to go with this option instead of implementing the solution by yourself. And one of the challenge when working with Spring Boot applications is people don't put focus on upgrading their versions, application dependency versions to the latest version, and they continue building the features over the years. and then they reach to the point where the used version may go out of support, and then if they try to make it try to upgrade, it is going to be a huge because if you skip many major versions and then if you try to upgrade, that usually is a little bit painful. Instead, we should aim for upgrading even minor versions through some automated way. So usually it is very simple if you are migrating even with the smaller minor versions as well. But let's say you are on Spring Boot 2.x. Directly upgrading from 2.x to 4.x is very difficult. There could be a lot of breaking changes and all that. But whereas if you want to, let's say you are on Spring Boot 3.x, and over the time, if we keep on upgrading within the 3.x itself, like 3.1, 3.2, 3.5, and upgrading from 3.5 to 4.x is relatively much simpler than directly upgrading from 2.5 to 4.x. So how can we upgrade these in an automated fashion? So there are many ways, but there are certain things that can be automated. There are certain things you have to explicitly take a look at it and then fix it. So my recommendation is, if you are using GitHub, probably you already might be aware of the tool called Dependabot, where you can configure some XML or ML file, and it is going to automatically periodically check if there is any newer version of library that you are using, and then it automatically creates a PR to upgrade that library. There is another tool called Renovate, which is also again provides GitHub integration, and it also keep on checking if there are any newer libraries and then automatically creates PR. So this way you can continuously get the updates and make it simpler to update to newer versions. You don't have to wait and then one fine day after 6 months or 1 year you check, okay, what is the newer version now? You don't have to do that manually. Instead, you can use these tools which automatically checks it for you and even create PR for you. For example, I am using that for my, let's say, Spring modular monolithic application, and I have this Renovate JSON configuration. I just use the default, which means it keeps running on certain interval and then automatically rise a pull request, something like this. So here it already saw that my application is using so-and-so library, and it identified there is a newer version. Earlier I was using 2.10, there is a newer version. So it automatically created the PR for me. And if you have proper test suite and all, as soon as this PR is created, you can run the test suite, and if everything is fine, you can simply merge it. But it is, so that's why it is very important to have the proper test suite so that you can automate all these version upgrades. You don't have to do it manually. So in this case, I have all these things. Recently, I have not updated it, but if I have to update it, I just takes care of taking a look at it and simply merge it. I prefer the Renovate over Dependabot because it is very much simpler. In my opinion, it is much feature rich. You can configure the Renovate. Let's say I don't want to get these PRs every day. Instead, I want to check once a week. You can configure at what point of time you want to check for the newer versions. So things like that, there is much more configuration support available in Renovate. So I would recommend you to check this out and try to use this. And you can simply check the PRs and then commit it. Let's say I want to upgrade my application to this. I find this is fine. Probably I can simply merge it, as simple as that. But here one thing is, whether it works, if you simply match the pull request, whether it works or not, that depends on how good your test suite is. If you have proper test suite, then it already checks the compatibility and the features are not breaking and everything, that works fine. But what if there is no compilation issues, but it is not compatible at the library level? Is that fine? So that is where the other open rewrite comes into picture. Let's say we are building an application for many years, and some tests are there using JUnit 4, and we are writing some newer tests using JUnit 5, and we want to upgrade the JUnit 4 test to JUnit 5. It is not simply upgrading the dependency versions itself. There is a change in the code also. So that code update is not going to taken care by these tools. This is where open rewrite comes into picture. Open rewrite helps you. Let's say you want to upgrade from JUnit 4 to JUnit 5 or JUnit 5 to JUnit 6, something like that. And you can use open rewrite recipes, and you can say upgrade to this, and it is going to take care of actually making the code changes accordingly. For example, again, taking a look at this, you can integrate that with your build tool. In this case, Maven, I am using that. So here I have configured the rewrite Maven plugin. In this case, I configured only one recipe, upgrade Spring Boot 4. Let's say if this application is 3.x, I can use this recipe, and then I can run rewrite run goal, which is going to automatically take care of trying to upgrade to the 4.x version. I mean, again, this is not like 100% guarantee that your application is going to be properly migrate to the newer version, but they do their best. They try to do the migration as well as possible, but still there could be scenarios where you have to explicitly do some modifications. But still, even with a combination of renovate, where it helps you to upgrade to the newer versions, and then open rewrite recipe, which kind of automates some code changes. So there is much better automation to migrate to the newer versions. So I would say this combination already cuts down the effort to migrate to newer versions to a great extent. So I strongly recommend to use this because this is where many companies end up spending so much time, because they have not updated frequently. Down the line, 1 year or 2 years later, this itself, upgrading to the newer version itself, become a big project, and then people bang their heads with all the breaking changes and all those things. So I would highly recommend to check this out and make it migration is smooth. Any questions around this? Okay, go ahead.
Yeah, my question is, around, the application updates. Yeah, so for example, let us say I have like a Spring Boot application that is still running on 2 points, right? And currently there is about 4.0 version. So now I want to like upgrade to at least 3 point or something. Now if I go to the to start.spring.io, I won't like see all the versions before prior to 4 points. So like, is there any place where I can see all the minor version upgrades so that I can incrementally upgrade until I've gotten to, for example, 3.5.4? Yeah, that's my question.
So usually they don't show all the versions, only they show very small subset here. But if you want to check the previous versions, maybe you can go to Maven repository and you can see all the versions here.
Okay, great. Thank you very much. I appreciate it. Thanks.
Yeah. So apart from this, production readiness. This is the most important thing where uh, many times we focus on the feature development and we may not put more focus on what happens if something goes wrong in production, how easy or difficult it is to debug. So because if something is not working in production, and if you take a lot of time to figure out, that is kind of a not acceptable for a certain type of applications, because you are supposed to provide 999 kind of a uptime and all those things. So the best way is to have proper monitoring in place so that as soon as something goes wrong, you should be able to figure out what is going wrong here, and so that you can immediately take an action. And not only monitoring, you need to make your application in a resilient way, where if something goes wrong, let's say there is a memory leak or some other down services are not responding properly, your application should handle that kind of a situation in a graceful manner. So recently, some of the features that were available in third-party libraries like Spring Retry or Resilience Fuzzy, some of them are already made as part of the Spring Core framework itself, where you can put timeouts or you can put circuit break and not circuit breaker, how many times you want to, how many threads can be accessible. So those couple of features were moved into Spring framework itself. But I would say in production grade applications, still you might need a library like Resilience Fuzzy, using which you can implement a circuit breaker. Let's say in a microservices application, you are calling one service, but that service again calling some other services. And if those services are slow in response, it is going to slow down the whole hierarchy. And if it is slow, what happens if you put more and more pressure on them? So they are going to die. They are not going to be responsive. So in that case, you should have the circuit breaker implementation where you can see within a certain window, if there are more failures, you can assume that right now it is not able to serve. So there is no point in again making a call and then trying to see whether it works or not. Instead, you can automatically assume that for now it is down, return a failure response, and let the service heal itself and then become back again. So those kind of resiliency features that you should take into account, especially with the microservices and everything. I would recommend to check out this resilience fuzzy. And monitoring, Spring Actuator is one of the beautiful library that, in fact, when Spring framework, Spring Boot is not yet created in our application almost 10, 15 years ago, we were using Spring framework, and then just Spring Boot got released. And I suggested my team, my manager, that hey, this new Spring Boot came into picture, and it seems very simplifying the Spring application development. And my manager was a little bit skeptical. Why should we upgrade? What kind of additional features we are getting, so on and so. And then I demonstrated the actuator features. Like, we were having a lot of custom setup using JABX monitoring and checking for hard disk space, checking for memory, all those things. We have a huge setup for monitoring purpose. And most of those features are automatically provided by Actuator. You just have one starter added, and you can just get the data like how much disk space is left, how much memory is left. All those things are automatically provided. Just my manager looked at the Actuator feature and just gave me a green light, like, let's go. So this is one of my favorite feature in entire Spring Boot ecosystem. And there is recently Open Telemetry become kind of a standard where you can monitor all the tracing and logs and all those things. So Spring Boot already provides a very nice integration with all these tools. Let's take a quick look at them. Again, for this modular monolith, let's take a look at. Okay, let me revert this. So I'm using one tool called task file, which has nothing to do with Spring Boot or anything. It is a simple utility where if you want to automate certain repeatable commands, you can simply define them as a task and simply call task and call whatever. So for people like me who can't remember long commands like this is very handy. So it's a nice utility if you want to check this out. Okay, what happened? Okay, I think there are other containers running. Let me go ahead and kill it. So here in this application, I am monitoring things with this application is using PostgreSQL database, RabbitMQ, and I'm using Grafana stack for monitoring all these things. And I have configured the metrics endpoint, traces endpoint, logs endpoint, and all those things. So with that, okay, still, okay, this is the problem. So for monitoring, I have the entire Grafana stack here. So it integrates using open telemetry support. And here, if you take a look at dependencies, so I have open telemetry starter, and also for log support, I have added a log back appender. And also for monitoring database queries, I have the data source micrometer Spring Boot dependency. So with these dependencies, let's see, okay, everything is started. And if I go to, let's say, okay, it's a very small application here. Let's log in, and I want to buy a book, and I place an order, and I can check out some orders. So, okay, this is fine. Now I can log in into Grafana. And here, if I try to explore, let's say I want to check the logs. So here I will select the application this, and for the last 5 minutes. So here already all the logs are streamed here, and you can leverage all the facilities provided by Grafana Loki to identify them. And also you have a tempo that stores the traces. So here, if you take a look at, let's say this is a API call to / products API endpoint. Here you can see the breakdown, how much time it is taking for executing the request, executing the database query. So all this is already tightly integrated and provides a much better monitoring support. So I would say you should definitely explore and use these monitoring features. And if something goes wrong, our monitoring support should give us cue that where the things are going wrong, and as specific as possible, your support system should be pinpoint which component is malfunctioning, where can we identify this. So we should be really focusing on this one. So that's all I have. If you have any questions, I'm happy to answer them. I'm going to stop sharing. Yeah.
All right, great. Yeah, thank you, Mr. Prasad Reddy, for such an amazing session.
You're welcome. Thanks for having me.
Yeah, thank you very much. And also thank you everyone for for being here. So we'll open the door for for questions, right? So please raise your hand up, then we'll call you and you give your questions. All right. Thank you. Okay, so there is a question on the chat box about the material that is the material to this lecture. Yeah, Donald, you get the material to this lecture after that, and also
let me share a couple of things. So the books that I showed in my profile, they're a little bit old on Spring Boot 3. If you want to explore, recently I published something, learning path. So there is a Spring Boot learning self-learning guide. So here I put together most of the important concepts, and probably this can help you. This is based on the Spring Boot 4, so this could be helpful.
all right, great. Thank you. So I have a question. I have a question on the open telemetry parts, the parts you showed, the Grafana UI and the monitoring and logs, right? So I just want to know, like, what is the best practice on that logging part? Because I see that it is not authenticated. So let us say if my application is authenticated, right? Should I expose that endpoint as that is an unauthenticated endpoint, right? Now, if I should make it authenticated, so how do I pass my token to that? Given that it is a web-based stuff, right? That Grafana UI is a web-based stuff. So, is there any way like to to log in to it and see it here?
So because this is a demo, I haven't put any authentication in place and make it available without login. But usually this is a support system, right? This is not a public facing system that you expose to the public. Most of the times, these are kind of maintained by the DevOps team where with all the authentication mechanism in place. And probably that can integrate with your system, other system login within your portal. Like most of the organization use some kind of a single sign-on. Maybe you can integrate with that, and you don't expose these support systems to the public usually. That they run in a private network and is only available for support engineers. So that is how you can integrate. And also, if you want to make it more secure, you don't expose actuator endpoint publicly. Only you expose only for authenticated users, and then you can use Spring Security support only to scrape the metrics and all that in a secure way. So that way you can limit the access to the internal components only to the support system, but not to the public.
Okay, thank you very much. Thank you. That was a great one. Thank you. So, Janet, your hand is up. You can go ahead or mute and ask your question.
Okay, thank you very much, sir, for this session. Good evening, everyone. Okay, so I have two questions. When you overrode that was at the beginning in the application of properties, you overrode page.size from 5 to 25. You didn't get how you did it. And then my second question is, do you have classes that you take for those that want to advance in Spring Boot? if there is something like that available. Thank you.
I get the first question. I'll come back to the second one. So in a Spring Boot application, your usual configuration, the default configuration, go into application.properties. So here I have configured a property page size equals to 10. So if I simply run my application without enabling any profiles, my application start with a default profile. Let's go ahead. Earlier we enabled this, and let's remove this as well. Now, okay, so if I run the application now, it is going to be
sharing your screen. Sorry, I think your screen is not being shared.
Oh, sorry.
Yeah.
Okay, so now, okay, so here I was saying this is my default application properties. I have this configuration as page size equals to 10. Now, earlier I activated the profile here, local, and also overridden environment variables. I removed all that configuration. Now I have a plain Spring Boot application, no customization. Now, if I start the application here, the application will start no active profile set, falling back to the default profile, which is nothing but application-properties. It doesn't load any other properties file. But let me, okay, so, but if I enable a profile, so during the development, we can simply enable any profile here from IntelliJ. But in production, if you want to run in a different profile, you can use a system property like Spring Profiles Active. This is a property that you can use to enable whatever profile you want. So like this, you can enable. But in IntelliJ, you can simply enable a profile local. Okay, now if I start the application, you can see the following one profile is active. What does this mean? It means first it is going to load all the properties from application.properties. And then if there are any properties here, these values are going to be taken high priority, and this is going to withdraw, like page size is not 10. This is overridden from this configuration. That is how we can override this. Is this answered your question?
Oh, yes, thank you very much.
Yeah, and you have another question. Sorry, I couldn't get it. Can you repeat it for me?
Okay, I asked, do you have a class where you train people that are interested in Spring Boot?
I have a YouTube channel. So if you want, you can take a look at the playlist. There is, if you are looking for building one application end-to-end, you can take a look at the URL shortener playlist. It starts with complete new and then complete one application. If you are more interested in building microservices, there is the microservice complete guide, kind of 12 hours or so. You can take a look at it. If you are interested in Spring AI, again, there is another playlist, complete tutorial. And yeah, I published many videos around Spring. You can check this out. Let me give a link here. I don't have any paid courses. I share everything I learned on my YouTube channel for free. So you can access all this.
Yeah, thank you very much. Thank you.
Yep.
Yeah, so just a follow-up question on the properties file. Yeah, I want to ask, like, what is the balance between using the properties file and system.get env? Is it okay to use system dot, because I've worked in a code base where there's a properties file, but most of the variables we are getting from system.env, which I believe that the values were injected from the server or something like that. So in that case scenario, like, what is the best practice? Do we go with the properties file, or do we go with system.get environment variables?
So if you directly use system.get environment and then get the values, you limit yourself with system environment property values only. Whereas if you go with the Spring infrastructure of property files, which can be overridden by environment variables, and also you can use AWS security manager or parameter store, you can override in a much, you have much scope. Like if you want to change where you want to store the configuration, you have all these options. But if you directly use system.get environment, you are limited to only that option. So I would say Spring's infrastructure management, configuration management gives a much more flexible option than directly using getting environment variables.
Okay, great. Thank you very much. Yeah, thank you. Yeah. Please, more questions, guys. More questions. All right. I believe there are no. Okay. Are you saying something, Mr. Reddy?
No.
Okay, great. So I believe there are no more questions. Yeah. So thank you, Mr. Reddy.
Mr. Jones, can you check the message box? Someone is saying something.
Okay, message box. All right. All right. So okay. Yeah, thank you, Mr. Yasin. Yeah, thank you, and you're welcome to the community. Yeah. All right. So thank you, Mr. Reddy, for such a powerful session. I wish you can go on and on and on and on, because you actually went deep into what we don't really know, even after working with Spring Boot for a while. But these things, for me actually, most of them I don't really know them, right? So thank you very much. We hope to have you next time.
Thank you for inviting me. It's nice presenting here.
Yeah, thank you. We are privileged to have you. Thank you very much. And to everyone that showed up, thank you very much for showing up. And please, we have like a community of developers, right? Like I told you earlier, it's called the NAIJA Java user group. And one thing is not limited to Nigerians alone, but to Nigerians and beyond, right? And I've also dropped the link, which I'll also be dropping now, the link to our various communities. Please feel free to join. We have boot camps, boot camps, which is currently ongoing, where we train developers all free of charge. You don't pay anything. It's all community driven. And we have knowledge sharing sections and lightning talks, monthly sections like this. So guys, feel free to join, right? Okay. Kevin said, can we have another session that focuses on single topic, e.g. security? Great. Please, Kevin, join the group. We'll have more monthly sections coming up, and also lightning talks, and there are boot camps also. Yeah, you'll get more information on that. All right. Thank you very much, everyone. And at this point, we'll draw. Okay. All right. All right. So also feel free to reach out to Mr. Reddy, on his LinkedIn, Twitter. Yeah. So and so we'll be sharing his, LinkedIn and Twitter handle on the group chat, just in case. Yeah. So thank you everyone for joining, and we'll draw the curtain here. And until next time, take care. Bye-bye. All
Bye-bye.
right. Yeah.